Okay, we're going to be looking at note card 5, continuity of a function. And basically, for continuity, there are different ways of explaining. There's a graphical way of explaining what continuity is. But the way on the left, there are 3 conditions that have to be met. That is the official, formal way of defining or proving continuity. F of C, if a function is, f is continuous to C, if the function is defined at that value. So that's one condition. The limit as x approaches that value of C of the function f of x exists. And what do you have to have for a limit to exist? Left hand and right hand limit being equal. So part of proving continuity is proving the limit, right? After you prove the functioning, the function is defined. And then finally, in step 3, you compare what this is. You compare what this number is to this number. So number 3 is just looking at these 2 numbers. And if these numbers are the same, you've proven continuity. If these numbers are different, you do not have continuity. All right, so it's a very formal way, and these steps are what you need to write out. Now, graphically, what that looks like is this. Graphically, it looks like, continuity looks like when you can draw something without lifting a pencil up, that is continuity. All right, so graphically you see that. If you see something like this, where there's a limit, but there's a break, is there continuity here for this one? No, there is not. Which condition fails for this one below here? Which condition is not met? The first condition, f of c is not defined. Sometimes what you'll do is you'll see a situation like this where you'll have the function defined at a point, but what would this situation be where you had this whole function with this and this? What would happen for these conditions here? Okay, f of c is defined, right?
Yeah, the third one.
The limit exists, but the third condition is what? They have to be equal to each other. So the limit here is not going to be equal to that. So therefore it would fail at condition 3. So you have to be systematic in going about this. Now, properties of continuity are if sum and difference, product. If 2 functions are continuous, for example, if a function f is continuous, if you multiply that continuous function by a scalar, the resulting function is still going to be continuous. So continuity will be preserved even when you multiply by. If a sum and difference, if you have 2 functions, f and g, both of which are continuous, and add those together, by definition, the sum of those 2 functions will be continuous. If you have a product of 2 continuous functions, that product will be continuous also. And finally, for quotient, they will be continuous except where the denominator is not equal to 0. What would happen if the denominator was equal to 0? Yeah, usually you'd have a vertical asymptote, but you could have a hole there too, right? Mm-hmm. So you would have then than a composition of functions. So now we're going to go look at some examples of that. And here we're given an example using h below for what values of x is h not continuous. So for number 1 here, what would be the critical numbers you'd have to look at for evaluation? What x value are you concerned about here? Negative 2. So you basically look over here, and this piecewise notation is kind of strange. We just briefly touched on it last year in pre-calculus, but this is the way it reads. And sometimes you'll see commas here too, but this is the way it reads. H of x is negative 2x plus 3 when or where x is less than negative 2. H of x equals 3 where x equals negative 2. And finally, h of x is x cubed minus 6x plus 3 where x is greater than negative 2. And so let's go about our conditions here. 1 and then the critical value here is 2. So we can call this a critical number. So h of negative 2 is equal to what? 3. So we know that this exists, right? So which condition did we meet here? Remember the conditions I had? 1, 2, 3 conditions. Which condition was met here? The first condition. Okay, and I just wrote number 1. 2, what are we trying to look for condition 2? If the limit exists. So we write down limit as x approaches negative 2 from the left side of h of x equals limit as x approaches negative 2 from the right side of h of x. And so what do we do for that? Just plug in negative 2 for this, right? So I see this x is less than, so I think that's going to be left side here. So negative 2 times negative 2 plus 3 equals, we have negative 2 cubed, and then negative 6 times negative 2 plus 3. Is that right? So on the left side, what do we have?
7.
We have 7, right? 4 plus 3 is 7. And on the right side, we have, that's going to be negative 8. Is that right?
Yes.
Negative 8 plus 12, which is negative 8 plus 12 is 4, plus 3 is 7. So we know that, so therefore limit as x approaches negative 2 of h of x exists and equals 7. Now what conclusion can we make in step 3? Yeah, okay, we would articulate this since h of negative 2 equals limit as x approaches negative 2 of h of x. We'll have h of x is continuous at x equals negative 2. Okay? So just the steps. All right, questions on that? So that's the basic concept of continuity. So we're just about to the end, if I'm not mistaken, of our class period. So I think we'll just, pardon me?
three.
about 2 or 3 minutes. So let's just go ahead and just call that